Assalamu alaikum and welcome to Mathcast with Faria Yusuf, and this is going to be the 9th lesson on trigonometry. And in this lesson we shall be doing the graphs of tangent functions. And again, for the graphs of tangent function we should be knowing the axes coordinates, and the axes coordinates here are for 0 degrees or 0 radian, tan of 0 is a 0, tan of 90 degrees or pi by 2 radian is infinity or undefined, tan of 180 degrees or pi by 2 radian is a 0, tan of 270 degrees or 3 pi by 2 radian is infinity or undefined, tan of 360 degrees or 2 pi radian is a 0. So here I can say that the axes values for tangent graph, they are ranging from 0. They have the values as either 0 or infinity, meaning on the axes I should be having a 0 or an undefined value. So here I should be adding some more values that will give us one whole number value, which are tan of 45 degrees or pi by 4, which is a 1, tan 135 degrees or 3 pi by 4, which is a negative 1, tan 225 degrees or 5 pi by 4, which is a 1, and tan 315 degrees or 7 pi by 4, which is a negative 1. So these are the basic values which I will be considering while making the graphs of the tangent function. So let's quickly look at the graph of the basic tangent function. So on this graph here that I have sketched, I have the basic x values. I have the basic x values which are 0, pi by 2 degrees or 90 degrees, pi 180, 3 pi by 2 or 270, and 2 pi or 360 degrees. And as we know, at tan of pi by 2 or 90 degrees, it has to be undefined. Therefore, here I have made the asymptotic line. Undefined function, they can never be sketched, but we know that the curve gets close to the asymptotic line, but there is no definite value. The function here is undefined. Same is at 3 pi by 2 or 270 degrees. Again, the dotted line shows the asymptotic line, and here I can see that in the first quadrant from 0 to 90 or pi by 2, the graph is a curve getting close to the asymptotic line. Tan of 0 is a 0, and I can see that this curve lies along the positive y-axis. All the y values, they are positive here. Tan of pi is 180. In the second quadrant, our tangent is a negative, therefore this curve is asymptotic towards negative infinity at 90 degrees or pi by 2. Third quadrant, 3 pi by 2 or 270 degrees, it's asymptotic again. And in the third quadrant, as we know, the tangent is positive. The curve goes upward towards the positive asymptotic line towards positive infinity. And then in the fourth quadrant, as tangent is negative, we can see 2 pi is a 0. And at 3 pi by 2, the curve is towards the negative infinity here. So this is the graph of the basic tangent of x, which is y equals tan of x here. Now here I can see that for the cycle of the tangent function, the first cycle here gets completed from 0 till 180 degrees or 0 till pi radian. And then from pi till 2 pi, I can see the same cycle being rotated, and therefore from pi to 2 pi I can see the second cycle here. So therefore here I should know that the graph of y equals tan of x is periodic. The graph of y equals tan of x is periodic and has a period of 180 degrees or pi radian. So unlike sine and cosine, which have a period of 360 degrees or 2 pi radian, the tangent graph has a period of 180 degrees or pi radian. So this is one thing that we should be noting down here, that the period of tangent is 180 degrees or 300 or the second cycle is from 180 till 360 degrees. To discuss the properties of the tangent graph, I have this graph which ranges from negative 360 up till 720 degrees, meaning from negative 360 to 0, these are all the clockwise angles that I have, and then here onwards I have all the anti-clockwise angles. So what we know here is that tan of minus x, meaning the angle in the clockwise rotation, tan of minus x, 0 to minus 90, it's the same curve, but it's just that we can see the change in the signs, the positive and negative. From 0 to 90, the sign of tangent x is positive, and whereas from negative 90 till 0, the graph shows negative curve. Therefore, I can say tan of minus x equals minus tan of x. Tan of 90 plus x, tan of 90 plus x when we are moving towards the second quadrant, that equals negative tan 90 minus x. We can see the similarity. It's just that it's having a negative sign. So this is one of a unique property of the tangent function here. Or if I go by the basic angle and the general angle, I can relate them as tan of 180 minus x, which is equals to negative tan of x. The second quadrant property here. Then for the third quadrant, 180 till 270, all the tangent values, they are positive. Therefore, tan of 180 plus x equals positive tan of x. And then in the fourth quadrant, 270 to 360, again the curve is negative towards the negative y-axis. Tan of 360 minus x shall be equal to negative tan of x. So these are the few properties that we should be knowing with respect to the tangent function here. Range of y equals tan of x for any real value, as we know that the graph here is undefined. It has infinity values towards both the positive and negative y-axis. Therefore, it's negative infinity lesser or equal to tan of x, which should be lesser or equal to infinity. So they are just defined for any real value of x here. So this is what we should be knowing about the tangent graph. So the first question says, sketch the graph of y equals tan of theta minus pi by 4 for 0 lesser or equal to theta lesser or equal to 2 pi. So first we need to understand what tan times theta minus pi by 4 means. So y equals tan theta minus 4. We have done the transformations and we know that whenever it's the bracket angle for theta minus pi by 4, then it has to be a horizontal translation by pi by 4 and a 0, meaning this entire graph for tan of theta is getting translated horizontally towards the positive x-axis by pi by 4. Meaning here, our 0 angle should be 0 plus pi by 4, giving us a pi by 4. Pi by 4 plus pi by 4 should be a pi by 2. Pi by 2 plus 3 pi by 2 plus pi by 4 should be a 3 pi by 4, and then uh, 3 pi by 4 plus all the values here, we can see that they are getting translated by a pi by 4. So I have sketched all the points. I have located all the axes values 0, pi by 4, pi by 2, all in the interval of pi by 4 here, because every axis angle, and for tangent we know that pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4 has their own importance, as discussed earlier with respect to the tangent graph when we said that 45 degrees, 135, 225, 315, they also give us significant values, which are 1, negative 1, 1 and a negative 1 here. So I have sketched or located all the angle values with respect to 1, negative 1, 1 and negative 1 also. So what we can do here is, I have marked in yellow the original points on the graph where tan of 0 is a 0, tan pi by 4 is a 1, and then pi by 2 is infinity. Tan 3 pi by 4 is a negative 1, tan of pi is a 0, tan 5 pi by 4 is a positive 1, and then tan 3 pi by 2 infinity, asymptotic here. Then tan 7 pi by 4 was a negative 1, and then 2 pi, that was a 0 here. So these are all the points that we should be having with respect to the original y equals tan of x graph. But here, as the question says, it should be translated by pi by 4 towards the positive x-axis. Therefore, simply what I have done is I am just moving this 0, which was giving us a 0 value, to pi by 4. This 0 moved to pi by 4. Pi by 4, which was a 1, moved to pi by 2, because pi by 4 plus pi by 4 gives me a pi by 2. Pi by 2, which was infinity, now has infinity or asymptotic at 3 pi by 4. 3 pi by 4, which was a negative 1, has moved to a pi, which gives us a negative 1 now. Pi, which was a 0, should move to 5 pi by 4. 5 pi by 4, which was a positive 1, should give us a positive 1 at 3 pi by 2, and then 3 pi by 2, which was asymptotic here, should be asymptotic now at 7 pi by 4, and 7 pi by 4, which was a negative 1, should now be at 2 pi. So this is how the graph just moved towards the positive pi by 4 direction. And then when theta is a 0. Theta is 0 radian. I've just substitute the theta as 0. I'll be left with tan negative pi by 4. Tan negative pi by 4 equals negative tan pi by 4, and I can say it's a negative 1 here. So this is how then I have sketched this graph for y equals tan theta minus pi by 4 here. So this is the sketch for this question. Now let's start some questions from the past papers. So the second question that I have on my list is from winter 2010, and it is paper 1 variant 1, and the question says that a function f is defined by fx equals 3 minus 2 tan 1 by 2x for 0 lesser or equal to x less than pi, and then we have to state the range of f. This is just a 1-mark question. That means it just requires a lot of understanding here. So we should be doing the working just by understanding the equation and the transformations that are taking place here. So if it is f of x, part 1, if this is f of x, which is equals to 3 minus 2 tan 1 by 2x, and the domain here is for 0 lesser or equal to x, which is less than pi. So with 0 lesser or equal to x, which is less than pi radian, then what I should be knowing here to get the range is that I have 3, which should be the mid-axis. I know all the transformations now. This 3, it's the mid-axis, or it's the vertical translation. It's the vertical translation. It's the vertical translation with 0 and 3. The negative sign, that means it should be the reflection in negative with tan of x. It means it's the reflection in the x-axis, and this holds a great importance, reflection along the x-axis. And we have this 2. This 2 is actually the amplitude. We know it's the amplitude, and also it's the stretch parallel to the y-axis. To the y-axis by factor 2. And then we have this 1 by 2 here. So x with a 1 by 2, that means there is a stretch parallel to x-axis also. And the factor for this stretch has to be a 1 divided by 1 by 2, which then shall be equal to a 2. So these are the things that we should be knowing about this given function for tan of x. Now, if they are asking us for the range of x, then for the range of the function here, then for 0 lesser or equal to x less than pi, I can just substitute my tan of 0 here. With tan of 0, if I substitute tan of 0, So I can say it's f of 0, which then shall be equal to 3 minus 2 tan of 0, which actually is a 0, and then I will be left with a 3 here. Now, f of and other values that I should be having here are going to be f of pi, and with f of pi, this then is going to be 3 minus 2 tan. Substituting x with a pi, this becomes pi by 2. Tan of pi by 2 is infinity, and therefore this function value here then shall be undefined. But then as function value here is undefined, then we have to take into account the negative sign. The negative sign here with the tangent function, it holds a great importance for giving the range of this function. Now we know that the negative sign with the function, with the tangent function here, it shows that it has to be the reflection in the x-axis. That means if the graph for y equals tan of x for 0 to pi by 2, if this would have been the graph towards the positive x-axis, then with respect to this negative sign, I would have reflected it along the x-axis, and therefore I would have gotten the curve, the tangent curve, which should have gone by the negative y values here. This is how this graph would have been. So without even sketching this graph, to give the range, I would have said that here f of 0 is giving me a 3, f of pi was giving me an infinity, and this negative sign tells us that this graph has to be towards the negative y-axis. Therefore, I should simply say that this graph here should be having the range which is f of x lesser or equal to 3. So just a 1 mark question, all done with respect to the understanding of the transformations that are taking place here. Second part of the function, state the exact value of f2 pi by 3. The second part of the question says state the exact value of f2 pi by 3. So again, the word exact is important. So we have to have the exact value f2 pi by 3. That means in the function f of x, just substitute 2 pi by 3 in place of x. So this becomes 3 minus 2 tan 1 by 2 and 2 pi by 3 in place of x over here. So 2 gets simplified, and I will be here left with 3 minus 2 tan pi by 3. And tan pi by 3 then shall be equal to 3 minus 2 under root 3. So this is going to be the exact value for this simple question. The third part of the question says sketch the graph of y equals f of x. So to sketch the graph of y equals f of x, which means it's a 3 minus 2 tan of 1 by 2x, and they have given us the domain which is 0 lesser or equal to x, which is less than pi here. So we have discussed the transformations that have been taking place for this graph. Now, another thing that we should be again observing here is this 1 by 2. That means it has a period. There should be a period for the tangent function. We know that the period for tangent is equal to a pi. So this pi should get divided by a 1 by 2, which then shall be give me a 2 pi. Meaning, in this case, one cycle gets completed, one cycle for this function for f of x here gets completed in 2 pi. And we have to sketch the graph only for 0 up till 2 pi. Therefore, the first thing was to get the period. And then the second thing would be to get the interval for this graph. And for the tangent, we know that the period of tangent is 0 to pi. Therefore, I know that it should get completed only within the two quadrants. Therefore, it's 2 pi divided by 2, which is equals to pi, meaning the first quadrant for this function 3 minus 2 tan x by 2 shall only be equal to a pi, and this is what we are supposed to make the graph for. So if I just have my values here for 0 to pi, for 0 to pi, then what I know here is that my function value is 3 minus 2 tan 1 by 2x. And then if I substitute my 0, I have already taken out the value which was coming out to be a 3. And then if I substitute f as pi, then this should be equal to 3 minus 2 tan pi by 2, which gives us infinity, and 3 minus 2 times infinity value, that would give us the answer as infinity here. Meaning at pi, I should be having my asymptotic value. And when it's a 3, when it's a 0, then my y value for this graph needs to be a 3. So this graph, again, we have a negative sign with respect to this graph, and we know that for the negative sign, we have already discussed that it should be the graph towards the y-axis. Therefore, simply, I should say that this graph shall be moving in this direction. So this is how the graph of y equals 3 minus 2 tan of x by 2 shall be sketched. And let's move to the last part of the question, which says, so the last part of the question, it says obtain an expression for in terms of x for f inverse x. So for f inverse x, obtain an expression. So I have the function which shall be equal to y, and this is equals to 3 minus 2 tan of x by 2. So to get this inverse function, I should say that it should be 2 tan x by 2, which shall be equal to 3 minus y, or tan x by 2 then shall be equal to 3 minus y divided by 2 here. And then I should be taking the tangent on the other side, so that this becomes tan inverse 3 minus y divided by 2. And finally, I can say that this x value is for 2 tan inverse 3 minus y divided by 2. So the final step is just to switch the x and y for the inverse functions. Therefore, f inverse x should be equal to 2 tan inverse 3 minus x divided by 2. And we know that for the function inverse, we have to flip the domain and the range to get the domain and the range of f. We already know the range of f. We got that range as f of x, which was lesser or equal to 3. So now for the inverse function, I should say that for the inverse function, our domain should be x to be lesser or equal to 3, and our range should be, again, we are just flipping the domain and range values, and I can say that the range is for 0 lesser or equal to f inverse x, which should be less than pi. So this is how this question needs to get solved, and I hope it's clear to each and every one of you. Next question is taken from summer 2017, and it's paper 1 variant 2, and it's question 10th in the paper, and it says that the function f is defined by fx equals 3 tan x by 2 minus 2 for negative pi by 2 lesser or equal to x, which is lesser or equal to pi by 2. And part 1 says solve the equation f of x plus 4, which equals 0, giving your answer correct to 1 decimal place. So let's start solving the equation. In place of f of x, I can simply substitute 3 tan of 1 by 2x and a negative 2 plus 4, which equals 0. Or I can say it's 3 tan 1 by 2x and a plus 2, which is equals to 0. And further, I can say it's tan of x by 2, which is equal to negative 2 divided by 3. Now here, there are a few things that I need to know. Number one, first is that we have been given the domain which is for x, and that is for negative pi by 2, lesser or equal to x, lesser or equal to a pi by 2. The first thing is to adjust the domain. So if I adjust the domain, it's an x by 2. So I should be dividing everything by 2, which can give me negative pi by 4 lesser or equal to x by 2, which shall be lesser or equal to a pi by 4. Meaning I have the domain which should range from negative pi by 4 till a pi by 4. Second thing is to locate the quadrant. So if I locate the quadrant, I can see that here it should be a negative 2 by 3 and negative pi by 4. If I just locate this here, negative pi by 4 is this angle. It's negative pi by 4, and positive pi by 4, it's this value, it's this angle here. Now, the tangent value here is a negative. Therefore, I should know that it should be lying in the fourth quadrant. So, lying in the fourth quadrant, tan inverse, I'm done with the location of the quadrant, so I can get the basic angle. And for the basic angle, I should say it's tan inverse 2 by 3. So tan inverse 2 by 3 in the radian mode gives me the angle as, so the basic angle here is going to be tan inverse 2 by 3, which comes out to be a 0.588. So as it is in the clockwise direction, so I should say that my basic angle is a negative 0.588. Therefore, x by 2 is equals to a negative 0.588, showing clockwise rotation, and therefore x should be equal to negative 0.588 multiplied by 2, which shall give us the answer as a negative 1.176 here. Let's move to the next part of the question. Find an expression for f inverse x and then find the domain of f inverse also. So to find the domain of f inverse also, that means again to get the f inverse, we know that the domain and range, they need to get flipped. So let's start working on this as well. So we know f of x that is given to us is 3 tan x by 2 minus 2, and the domain is given as a negative pi by 2 lesser or equal to x, which is lesser or equal to a pi by 2 here. So to get the range of this function, only if I substitute x by negative pi by 2, what I can see here is that for f of negative pi by 2, this shall be 3 tan 1 by 2 into negative pi by 2 and then a negative 2. So 3 tan negative pi by 4, which we know is a negative 1. So this becomes negative 3, or I'll just write it as 3 times a negative 1 and a minus 2, and I can say that this answer here comes out to be a 5, meaning f of negative pi by 2 gives us a negative 5. In the same manner, if I substitute x with a pi by 2, then I will be having 3 tan 1 by 2 and then pi by 2 in place of x and a minus 2. So 3 tan pi by 4, this shall give us a 3 tan pi by 4, which is a 1, and then a negative 2. That means here I am left with a 3 minus 2, which gives us a 1. So here very easily I can tell that the range of this graph shall be for, so here I can tell that the minimum value that I will be having within negative pi by 2 and a pi by 2 is a negative 5. So this is lesser or equal to f of x, and this shall be lesser or equal to 1. So I have the range as well as the domain of the graph of the function here, not the graph, but the function here. So this means that for the range and domain of the inverse function, I will just be switching the two domain and the range intervals that I have here. The question has asked us to get the expression for f inverse. So expression for f inverse, let's do the expression for f inverse. F of x or I can say is equal to y, is equal to 3 tan 1 by 2x and a minus 2. So I can simply say to get the F inverse, to have the F inverse, it should be a y plus 2, which is equals to 3 tan 1 by 2x, or I can say it's a y plus 2 divided by 3, which is equals to tan of 1 by 2x. And then further, I can say that this is going to be tan inverse y plus 2 divided by 3, which is equals to a 1 by 2x, or further I can say it's a 2 tan inverse y plus 2 divided by 3, which is equals to x. To get the inverse, again I know I need to flip x and y. Therefore, the inverse function here is going to be 2 tan inverse x plus 2 divided by 3, and just flipping the range and domain, of the inverse of the function itself, I will be getting the range and domain of the inverse function. Therefore, the domain for the inverse function is going to be from -5 till 1. So here I'll say that the domain of f inverse is going to be -5 for f inverse. This is going to be for the inverse function. So this is going to be lesser or equal to x, which is lesser or equal to a 1. And the range, if they would have asked for the range, then I would have said that the range is for -pi by 2 lesser or equal to f inverse x, which is lesser or equal to a pi by 2 here. So the answer to this part shall be for the domain, which is lesser or equal to 5, lesser or equal to 1, and then the expression for f inverse, which is 2 tan inverse x plus 2 divided by 3 here. Part 3 of this question says, sketch on the same diagram the graph of y equals f of x and the inverse. Function here is 3 tan x by 2 minus 2, and the domain that is given to us is a -pi by 2 lesser or equal to x lesser or equal to pi by 2. We know that there is a stretch along the x direction, and along the x direction we know that the period of the tangent function is a pi. Therefore, I should be dividing this pi by this 1 by 2 here. Therefore, I should be dividing pi by the stretch factor, which is a 1 by 2. So this becomes a 2 pi, meaning now instead of pi, the period gets completed in 2 pi, meaning the 2 quadrant for the tangent cycle now shall be having the interval of 2 pi divided by 2. Again, repeating divided by 2 because the tangent function for the tangent function, the cycle gets completed in 2 quadrants. So I'm dividing the interval by 2, which gives me a 2 pi divided by 2 as a pi radian, meaning the first interval has to be a 0 to pi. The first quadrant now is from 0 to pi, and the second from pi to 2 pi. This is how the cycle gets completed. And the domain here is from -pi by 2 till pi by 2. Therefore, here I have a pi by 2 and I have a -pi by 2 values here. If I substitute x with a 0, then with x as 0, this whole term becomes a 0 because tan of 0 is a 0 and I'm left with a -2. So this is tan of 0 as a -2 in this function. This -2 shall also be the mid-axis. Therefore, I have made this dotted line with respect to the mid-axis here. Then I have x, in place of x, I'm going to substitute pi by 2 because I know that again for the tangent function, the angle values as 45 degrees, which is half of 90 degrees, or a pi by 4, which is half of pi by 2, are of great importance because these give us a whole number value, which is a 1. So in this case, half of pi is going to be a pi by 2. So at pi by 2, if I substitute x here with a pi by 2, this function becomes a pi by 4. Meaning what I'm saying here is that my x here, if this is a pi by 2, then f of pi by 2 then becomes 3 tan 1 by 2 into pi by 2, and that should give me a negative 2, meaning this is 3 tan pi by 4, which is a 1 minus 2, or here I can say it's 3 minus 2, which gives me a 1, meaning when x is a pi by 2, when x is a pi by 2, the function value here is a 1. Then substituting tan of negative pi by 2, f of negative pi by 2, so this shall become 3 tan negative pi by 4 and a negative 2, or negative pi by 4 is a negative 1, therefore this is negative 3 negative 2, which gives us a negative 5 here. So f of negative pi by 2 gives us a negative 5. So f of negative pi by 2 giving us a negative 5, therefore this is the curve of the function 3 tan of x by 2 minus 2 over here. To get the inverse, we know that to get the inverse, I simply have to plot the values along the line as a reflection of the line y equals x here. So I have drawn the line y equals x. It's y equals x on this dotted line. And then if I sketch the inverse function, then this is how the inverse function sketch is going to be. Just a reflection of the original f of x curve along the line y equals x to give us the inverse function, which is f inverse x here. So the question says, sketch on the same diagram both the graphs of y equals fx and f inverse x. So this is how then this needs to be drawn. So these are the few questions which I have chosen for the tangent of x function. And let's end this graph here, and we will be meeting in the next video for more questions from past papers with transformation as well as sketching and solving the questions. So best wishes for everyone, and let's see you all in the next video. Thanks for watching, and Allah Hafiz.